Hello friends, welcome back to my channel Maths by Samit Deshmukh. So in this video we are solving last 3 example from exercise 2.3 of matrices. Already I have introduced two methods to solve linear equation in 2 variable or in 3 variable. One is inversion method and another one is what? Reduction method. In case of word problem, using the condition in the example, first we have to form the linear equation, and this linear equation we are able to solve applying any one of these 2 methods, either by inversion or by reduction. In case of word problem, there is no compulsion to use any one of these 2 methods. So applying these 2 methods, let us try to solve this example. So if you are new on my channel, subscribe the channel and hit the bell icon to get the notification of every newly uploaded videos. So observe the given condition in this example. So the cost of 4 pencil, 3 pens and 2 eraser is rupees 60. This is first condition. Second condition, the cost of 2 pencil, 4 pen and 6 eraser is rupees 90, whereas the cost of 6 pencil, 2 pens and 3 eraser is rupees 70. So 3 conditions are given to us, and using these 3 conditions, question is to find the cost of each item by using matrices. Using matrices, so in matrices we have seen 2 methods to solve the linear equation. So applying any one of these 2 methods, we are able to solve this example. But before that, we have to form the equation using given condition. So what is the question? Find the cost of each item. So how many items are there? 3 items. One is pencil, another one is pen, and last one is what? Eraser. Let us denote the cost of one pencil by rupees X, pen by rupees Y, and eraser by what? Rupees Z. And then we will use the condition to form the equation. So what is our supposition here? So let cost of a pencil be rupees X, a pen be rupees Y, and a eraser be rupees Z. So now we are using the given condition. So let us see what result we will get according to given condition. According to given condition, let us see what equations we will get here. So we have denoted cost of a pencil by rupees X. So how many pencils are there? 4. So cost of 4 pencil be 4x. How many pens are there? 3. Cost of 1 pen is rupees Y. So cost of 3 pen will be rupees 3y, and cost of a eraser we have denoted by Z. So cost of 2 eraser will be equal to 2z. And if we are taking addition of cost of 4 pencil, 3 pens and 2 eraser, it is given to us that this cost will be equal to how much? Rupees 60. So in this way we have got first equation using the given condition. In the same way, what will the second equation? 2x, because 2 pencils are there, so cost of 2 pencil will be 2x. 4 pens, cost of 4 pen will be equal to 4y, and cost of 6 eraser will be equal to 6z. Since z is the cost of 1 eraser, so cost of 6 eraser will be 6z, and this sum will be equal to 90. It is given to us. Then read the next condition. The cost of 6 pencil means 6x, 2 pens means 2y, and 3 eraser means 3z, and this total cost is equal to rupees 70. It is given to us. So according to given condition, we have got these 3 equations. Now to apply any one of the method, either reduction or inversion, first we have to write down this equation in matrix form. So matrix form of given equation, matrix form of given equations is, so let us write down this equation in matrix form. Already we have seen that whenever we are writing the equation in the matrix form, in first matrix we are collecting the coefficients of variable. In the first equation, what are the coefficients? 4, 3, 2. So here first collect the coefficient of x, y and z. In the second equation, these coefficients are 2, 4, 6. In the third equation, these coefficients are 6, 2, 3. In this matrix we are collecting variable. In this example, variables are what? X, Y, Z. And on this side collect the constant terms 60, 90, 70. Once the equation is written in matrix form, then apply the method to solve this equation. So to solve the equation, either we are able to use inversion method or reduction method. So I am giving priority to apply here reduction method, as this method is simple to comparatively to what? Inversion method. So in case of reduction method, what we have to do, we have to convert this first matrix either in the upper triangular or in the lower triangular, but we are giving priority to convert it into upper triangular. To convert it into upper triangular, what we have to do, all the element below this diagonal element should become 0. So how many elements are there below this diagonal element? 1, 2, 3. So we are trying to convert these 3 elements into what? Into 0, so that we can say that this matrix will be what? Upper triangular matrix. So first we are trying to convert this element into 0. So here this element is the element of second row, means our first operation is on R2. So what is the element of R2? 2. From 2 we have to subtract 2. But here 2 is not there. So here better way, I am multiplying to R2 by 2. So 2 into 2 will become what? 4. And 4 minus 4 will become 0. So here multiply to R2 by 2. So 2 into this 2 will be 4 minus 4, means we have to subtract what? R1 from it. Later on, next operation should be on what? R3. So what is the element of R3? 6. From 6 we have to subtract 6, and easily we are able to get 6 here, means we have to use the corresponding element of R2 and we have to multiply to R2 by 3, so that 3 into 2 will become 6 and 6 minus 6 will become 0, means we have to take the subtraction. So let us perform these two operations on the element of R2 and element of R3. Since our operation is on the element of R2 and R3, so keep the element of R1 as it is. So here element of R1 are 4, 3, 2, and on this side element of R1 will be equal to 60. Now I am multiplying to R2 by what? 2, and subtracting R1 from it. So multiply here by 2, 2 into 2 is 4, 4 minus 4 will become 0. Multiply here by 2, 2 into 4 is 8, 8 minus 3 will be equals to 5. Again multiply by 2, here we will get 12, 12 minus 2 will be equal to 10. Again here also multiply by 2, 180, 180 minus 60 will be equals to 120. Now perform this operation on the element of R3. Here we are using corresponding element of R2 and we are multiplying to R2 by minus 3. Multiply by minus 3. Minus 3 into 2 is minus 6. Minus 6 plus 6 will become 0. Multiply by minus 3, here we will get minus 12. Minus 12 plus 2 will be equal to minus 10. Again multiply here by minus 3. Minus 3 into 6 is minus 18. Minus 18 plus 3 will be equal to minus 15. And on this side, if I am multiplying by minus 3, here we will get minus 270. Minus 270 plus 70 will be equal to minus 200. Now if we are able to convert this element into 0, we can conclude that this matrix will become what? Upper triangular matrix. So our operation should be on R3. What is the element of R3? Minus 10. We have to add plus 10 in it. So we are using here corresponding element of R2, and if I am multiplying to R2 by 2, so 2 into 5 is 10 and 10 minus 10 will become 0, or minus 10 plus 10 will become 0, means we have to take the addition. And here we can observe that all the element of R2 are divisible by 5. To convert it into simplest form, just simply I am dividing to all the element of R2 by 5. So perform these operation or operations are on R2 and R3. So which is equal to, just to convert the element into simplest form, I am dividing by 5 here. Otherwise, if you are not dividing by 5, till we are able to solve the example, because this operation is not compulsory here. Just to convert this element again into simplest form, I am performing this operation. So keep element of R1 as it is. Here on this side also R1 as it is. Divide to the element of R2 by 5. So here we will get 0, 1, 2, and here we will get 24. Now perform this operation on the element of R3. We are using corresponding element of R2 and we are multiplying to R2 by plus 2. Multiply by 2, 0, 0 plus 0 is 0. Multiply by 2, here we will get 10, 10 minus 10 is 0. Multiply by 2, 20, 20 minus 15 is 5. Multiply by 2, so here we will get 240. 240 minus 200 will be equal to 40. Now, once this matrix becomes upper triangular matrix, then take the multiplication of these two matrices. Whenever we are taking multiplication of two matrices, we are multiplying by row to the column. So multiply by row to the column. See what we'll get: 4x plus 3y plus 2z. 4x plus 3y plus 2z. Now 0x plus 1 into y is y and 2 into z is z. So y plus 2z. Lastly, 0 plus 0 plus 5z will be equal to 5z. On this side 60, 24, 40, keep it as it is. So here we can observe that these two matrices are what? Equal matrices. And since the matrices are equal, so we are able to apply the definition of equality of two matrices. So apply the definition of equality. Therefore, by equality of two matrices, let us see what we will get here. So what we will get here: 4x plus 3y plus 2z is equal to 60. Let us denote it by equation number first. Then y plus 2z is equal to 24, denoted by equation number second. And what will the last equation? 5z is equals to 40 will be the third equation. Simplifying this third equation, easily we are able to obtain the value of z. 5 is multiplied on this side it will get divided, and here what will get? 40 divided by 5 will be equal to 8. In this way we have got the value of z. Once the value of z is known to us, if we are substituting this value of z in equation number 2, we are able to find out value of y, and substituting y and z in this equation, we are able to find out value of x, which are our required value. Let us try to find out now value of y. So now we are substituting, means putting value of z is equals to 8 in equation number 2. Let us see what we will get. So if I am substituting here z is equals to 8, so what we'll get here? Y plus 2 into 8 will be equals to, on this side 24, keep it as it is. Simplifying this, we are able to find out value of y. 2 into 8 is 16. 16 on this side will become minus 16. So 24 minus 16 will be equal to 8. Means in this way we have got the value of y. Once the value of y and z is known to us, substitute this value in equation number first. So put y is equals to 8 and z is equals to 8 in equation first. We get, let us see what we will get here. So here 4x, keep it as it is, plus 3 into y. Y means what? 8. Again 2 into z plus 2 into z. Z is also equals to 8, and the value on the right hand side will be equal to 60. 60, keep it as it is. So 4x is equals to, so observe here 3 into 8 is 24 and 2 into 8 is 16. 24 plus 16 is plus 40. Plus 40 on this side will become minus 40. So 60 minus 40 will be equal to 20. So x will be equals to 20 upon 4 will be equal to 5. Once the value of x, y and z is known to us, which are our required value, what is the question? To find out cost of a pencil, a pen and eraser. So x is nothing but cost of pencil. So therefore cost of a pencil is rupees 5. A pen is rupees, y means what? 8. And a eraser is rupees, it is also equals to 8, because z is nothing but cost of eraser. In this way we have got our required value, cost of a pencil, a pen and a eraser. Now see the question number 4th. Observe the condition in the given example. Here it is given to us that the sum of three numbers, if the three numbers are added, their sum is 2. So using this first condition, we will try to form first equation. Then second condition, if 2 times the second number is subtracted from the sum of first and third number, we get 8. And the third condition is if 3 times the first number is added to sum of second and third, we get 4. Using all these conditions, we have to find out the numbers using matrices. So let us denote these 3 numbers by what? X, y and z. And using this given condition in the example, let us see what equations we are getting here. So here already we have denoted these 3 numbers by x, y, z, and let us see what result we are getting according to given condition. Our first condition says that the sum of 3 numbers is what? 2. If 3 numbers are added, their sum is 2, means addition of these 3 numbers x, y and z will be equals to 2. It is given to us. This will be our first equation from the first condition. Now observe the second condition very carefully. 2 times the second number is subtracted from the sum of first and third. Sum of first and third. First number is x, third number is z. So x plus z. From this sum, which number is subtracted? 2 times the second number is subtracted. Second number means what? Y. So 2 times the y means 2 times the second number is subtracted from the sum of first and third. We will get what? We get 8. So which is equal to 8. So which implies that this equation can be written as x. Then write down the term of y. Which is the term of y? Minus 2y plus z will be equals to 8. Let us denote it by equation number 2. Now let us try to form the third equation using third condition in this example. So if 3 times the first number, 3 times the first number means 3x is added to the sum of second and third, is added to the sum of second and third. Second and third means what? Y and z. It gives what? We get 4. So this is the third condition. So this equation can be written as 3x plus y plus z is equal to 4. In this way we have got third equation. Once the 3 equations are known to us, so first write down these 3 equations in matrix form, since we have to solve this equation using matrices. So matrix form of equation is, so whenever we are writing the equation in the matrix form, in the first matrix we are collecting the coefficients. So let us check what is the coefficient of xyz in first equation. 1 1 1 1 1 1. In second equation 1 minus 2 1 1 minus 2 1, and in the third equation 3 1 1. Here collect the coefficients, collect the variables, and on this side collect the constant term. Which are the constant term? 2 8 4. So 2 8 4. Now we are trying to convert this equation into upper triangular matrix. So let us try to convert it in upper triangular matrix. For that purpose we have to convert 3 elements, these 3 elements which are below the diagonal element, into 0. So first, to convert this element into 0, our operation is on R2. What is the element of R2? 1. From 1 we have to subtract 1. 1 is already there in R1, means simply we have to take the subtraction of R2 and R1 to convert this element into 0. After this operation, this element will become 0. To convert this element into 0, our operation is on what? R3. So let us perform the operation on R3. What is the element of R3? 3. From 3 we have to subtract 3. So for that purpose here we have to multiply by 3 to R1 to get 3 here, and 3 minus 3 means we have to take subtraction here. So let us perform these two operations on the element of R2 and R3. Keep element of R1 on both sides as it is, and we know that in case of row transformation, post factor remains constant, means this matrix will remain constant. As it stands, there is no operation on R1, so keep element of R1 on both sides as it is. Now perform this operation on R2. R2 minus R1. 1 minus 1 is 0. So then here minus 2 minus 1 is minus 3, and here 1 minus 1 will become 0, and on that side also 8 minus 2 will become 6. Now perform this operation on R3. Here operation is on R3, but we are using corresponding element of R1 and we are multiplying to R1 by minus 3. Multiply by minus 3 to R1. 1 into minus 3 is minus 3, minus 3 plus 3 will become 0. Again 1 into minus 3 is minus 3 plus 1 is minus 2. Then multiply here by minus 3 plus 1 will be equal to minus 2. Multiply here by minus 3 will get minus 6 plus 4 will be equal to minus 2. Now we are dividing to all the element of R3 by minus 2. Let us divide it by minus 2 and see what we'll get here. 1, and parallelly I am dividing to all the element of R2 by minus 3 here, so that it will become 1. Just we are trying to write down this element into simplest form, so which is equal to, on this side keep element of on both side of R1 as it is, because there is no operation on R1. So R2 divided by 3. So divide to the element of R2 by minus 3. So what we'll get here, 0, 1, 0, and here 6 upon minus 3 will be equal to minus 2. Now R2 divided by minus 2, divide to all the element by minus 2, here we'll get 0, 1, 1, and here also 1. Now to convert this element into 0, our operation should be on R3. So what operation we have to perform? R3 minus R2 means 1 minus 1 will become 0. So let us perform this operation on the element of what? R3 on both sides very carefully. So here 1, 1, 1, keep it as it is, on this side 2 as it is, 0, 1, 0, because there is no operation on R2 also. So perform this operation on R3, 0 minus 0 is 0, 1 minus 1 is 0, 1 minus 0 is 1, and 1 minus minus means plus 2 will be equal to 3. Now once this matrix becomes upper triangular matrix, then remaining part is to take the multiplication of these two matrices, and we know that whenever we are taking multiplication of matrices, we are multiplying by row to the column. So let us multiply by first row to first column and see what we will get. X plus y plus z. So x plus y plus z is equal to 2. Now 0 into x is 0, 1 into y is y, and 0 into z is z. Means here we are getting only y is equal to minus 2. Here 0 plus 1 into z is z, and on this side 3. So here we can observe that these two matrices are equal matrices. That's why we are able to apply the definition of equality. By equality of two matrices we get. Let us see what result we will get applying the definition of equality of two matrices. So first equation, what we'll get? X plus y plus z is equal to 2. So x plus y plus z is equals to 2. Let us denote it by equation first. Then y is equals to minus 2, y is equals to minus 2, and z is equal to 3. Z is equal to 3. Once the value of y and z is known to us, substitute these values in equation number first. We will get the value of what? X. So put y is equals to minus 2 and z is equals to 3 in equation first. We get, let us see what result we will get here. Keep x as it is, replace y by minus 2, z by 3 is equals to 2. So x is equal to 3 minus 2 is 1, plus 1 on this side will become minus 1. So x will be equals to 1. So in this way we have got the value of x also, y also, and z also. That's why we can say that therefore required three numbers are what? X is equals to 1, y is equals to minus 2, and z is equals to 3. In this way we have got required three numbers. In this way we have solved the example using matrices. Now let us try to solve the last example from this exercise, question number 5. Here observe the condition in the example. The total cost of 3 TV sets and 2 VCR is rupees 35,000. It is given to us. The shopkeeper wants profit of rupees 1,000 on TV and rupees 500 per VCR. He sell 2 TVs and 1 VCR and get a total revenue of rupees 21,500. Using all these conditions, what we have to find out? Find the cost price and selling price of a TV set and a VCR. So we have to find out cost price and selling price of TV and VCR here. So let us denote the cost price of TV by rupees X and VCR by rupees Y. Now let us make the use of given condition in the example. These are what? Cost price. Even question is to find out what? Selling price also. So first let us try to find out selling price of TV. So therefore selling price of TV is equals to X is what? Cost price, and a shopkeeper wants how much profit? 1,000 rupees on TV. So if we are supposing that its cost price is X, then selling price will be what? X plus 1,000, because 1,000 rupees will be our what? Required profit. So cost price is X, so plus profit is rupees 1,000. If we are adding 1,000 in X, we will get what? Selling price of a TV. and selling price of second item is what? VCR is equals to rupees. What is the cost price of one VCR? Y. This is cost price, and we have to add what? Profit in it, and shopkeeper wants what? Rupees 500 profit on per VCR. So Y is its cost price plus profit is 500, means it will become what? Selling price. Now cost price we have denoted by X and Y, and selling price also we have got from the given condition. Now we are trying to form a linear equation by using given condition. So according to given condition, let us see what we will get here. So what is the first condition? The total cost of 3 TVs. Cost of one TV is rupees X, so cost of 3 TV will be 3X, and 2 VCR, cost price of one VCR is rupees Y, then 2 VCR will be 2Y, and the cost price of these 3 TVs and 2 VCR is equal to 35,000. It is given to us. In this way we have got first equation using first condition in the example. Let us denote it by equation number first. Now we are using second condition. He sell 2 TVs. What is the selling price of one TV? X plus 1000. So selling price of 2 TVs will be equals to 2 into X plus 1000. So this is selling price of 2 TVs and 1 VCR. What is the selling price of 1 VCR? That will be equal to Y plus 500. And sum of these two values is given to us 21,500. Let us write down this equation in the simplest form. 2 into X is here, we will get 2X, and here 1 into Y will be equal to Y. Then collect the constant term. So 2 into 1000 is 2000, 2000 plus 500 is 2500, plus 2500 on this side will become minus 2500. 21,500 minus 2,500 will be equal to 19,000. In this way we have got second equation. Once two equation from the given condition is known to us, we are solving this equation applying reduction method. But for that purpose, first we have to write down this equation in matrix form. So matrix form of given equation. Matrix form of given equation is, whenever we are writing equation in matrix form, in the first matrix we are collecting the coefficients of X and Y, in the second matrix we are writing the variable. In this example, variable we have denoted by X and Y. What are the coefficients? 3, 2, 3, 2, and what is the constant term? Constant term is 35,000, 35000. And in the second equation, coefficients are 2, 1, and constant term is 19000. Now we have two choices, either convert this matrix into upper triangular or lower triangular. So here we can observe that to convert this element into 0, we have to first take the LCM of these two elements. Instead of that, better way is very easily we are able to convert this element into 0. So that if we are able to convert this element into 0, all the element above the diagonal element will become 0, means matrix will become lower triangular. So we have two choices, either convert it into upper triangular or what? Lower triangular. Here easily this matrix can be converted into lower triangular. That's why I am converting it into lower triangular, means this element we are trying to convert it into 0. As it stands, this is the element of R1. So what is the element of R1? 2. From 2 we have to subtract 2. That's why I am multiplying to R2 by 2. And we are taking their subtraction, so that 2 minus 2 will become 0. So our operation is on R1. Perform this operation on R1 on both sides very carefully. So here R1 is 3, we are multiplying to R2 by minus 2. Multiply by minus 2, what will get? Minus 4 plus 3 is minus 1. Multiply by minus 2, here we will get minus 2 plus 2 is 0. Multiply by minus 2, here we will get minus 38,000. Minus 38,000 plus 35,000 will be minus 3,000. There is no operation on R2, so keep the element of R2 as it is. In this way, we have converted this matrix into lower triangular matrix. Then next step is to take the multiplication of these two matrices. Let us perform this multiplication and see what result we are getting here. So minus 1 into X is minus X, and 0 into Y will be 0. On this side minus 3000, keep it as it is. And here 2 into X is 2X and 1 into Y is Y. 2X plus Y will be equal to 19,000. Now both the matrices are equal matrices. That's why we are able to apply the definition of equality of two matrices. So therefore, by equality of two matrices, see what we'll get. Minus x is equal to minus 3000, which implies that x is equal to 3000. Simply minus and minus on both sides will get what? Cancel. Now and comparing second term, we will get what? 2x plus y is equal to 19,000. Now substitute this value of x in equation number in this equation. Let us denote this equation by equation number first. Put x is equals to 3000 in equation first. So here we will get 2 into x. X means what? 3000 plus y, and on this side 19,000. Keep it as it is. So here 2 into 3 6,000. 6,000 on this side will become minus 6,000. So 19,000 minus 6,000 will be equal to 13,000. In this way we have got the value of y. X and y are nothing but what? Cost price of television and VCR. Question is to find out cost price also and selling price also. So what is the selling price? X plus 1000, and selling price of VCR is y plus 500. So let us try to find out selling price also. From this value of x, we are finding x plus 1000. So x plus 1000 will be equal to, replace x by 3, its value 3000 plus 1000 will be equals to 4000. And later on we are finding selling price of VCR, which is nothing but y plus 500. Already the value of y is known to us. What is the value of y? 13,000. 13,000 plus 500 will be equals to 13,500. Once the value of selling price of TV and VCR is known to us, means we have got our required value. So lastly write down. So therefore cost price is rupees. X means what? Cost price of a TV, that is 3000, and VCR is rupees. Cost price of VCR we have denoted by what? Y. And what is the value of y here? 13,000. In this way we have got cost price of a TV and VCR. And even we have to find out selling price. And selling price of a TV is rupees. What is the selling price of a TV? So this is selling price of a TV, that is rupees 4,000. And VCR is rupees. What is the selling price of VCR? 13,500. In this way we have got our both required value. So here we have completed our last exercise in this chapter. In the next video we are starting miscellaneous exercise of this chapter. If you think that the videos are very helpful to you, so like the videos and share these videos with your friends also.